This is AS stats. We're in Unit 5, the binomial distribution. This is example 3. We're taking a wee look like expected values and things like that. In a bag there are 6 red counters, 9 yellow counters and 5 green counters. The counter is drawn at random from the bag, its colour is noted and then is replaced. This procedure is carried out 10 times in all. Find for part A the expected number of red counters. So we need to set up, because it hasn't green and then yellow, so for A we're going to have a different P and Q and so on. So for part A, probability then of it being a red counter is 6 out of the 20, so that's going to be 3/10. That means Q is going to be 7/10, and then is going to be 10. The expectation, or the expected value then of X, nice and straightforward, is NP, and that then is 10 times 3/10, which is 3. Of course you'd expect 3. If you're taking out 10, times, the probability of getting a red one is 3/10, obviously you would expect 3. Okay. Part B, most likely number of green counters drawn. So there are 5 green counters. So P is 5 over 20, which is a quarter. That means Q is 3/4, and of course then N is still 10. So it says the most likely number of green counters drawn. So that effectively means the one with the highest probability. And I mean, to a certain extent, I know because the probability is a quarter, 0.25, and out of the 10, are you expecting kind of 2 or 3 in and around there? But we're just going to do a bit of trial and improvement and see how we get on with it. So we'll try 4, and then we can kind of work our way down if we need to. So let's go for the probability of 4 green. So that would of course then be 10C4, and that would be a quarter to the power of 4, 3/4 to the power of 6. And if you put that into your calculator, you're going to get, as far as I can see, 0.145998. Let's try 3. So that then would be 10C3, a quarter to the power of 3, 3/4 to the power of 7. That gives us 0.2507. So it's getting bigger, so that's good. So you imagine that if you go to 5, then it would get smaller again. So probably have 2 would be 10C2, a quarter squared, 3/4 to the power of 8, 0.28156. And for my money, that's going to be our answer, but we're going to check 1 anyway. 10C1, quarter, 3/4 to the power of 9, and yes, sure enough, 0.1877. So that starts to get smaller again. So the one with the highest probability, I thought it was going to be 2 or 3 because of our probability there, is this one here. So our answer is, therefore, 2 greens is most likely. Okay. Part C. So we'll go back up. The probability that no more than 8 yellow counters are drawn. So our yellows, there are 9 of them. So our P then is going to be 9/20. Our Q then of course would be 11/20. 20ths, and our n, as ever, then is 10. No more than 8. So that would be 0, 1, 2, 3, 4, 5, 6, 7, or 8. So there's a bit of adding there to do. So we're very easier to do 1 minus 9 or 10. So let's write that. The probability of less than or equal to 8 yellows is the same as 1 minus probability of 9 plus the probability of 10. So let's do our calculations then for that. So that's going to be 1 minus, do a big square bracket, 10c 9, 9/20ths to the power of 9 upon 11 20ths plus 10c 10, 9/20ths to the power of 10, 11/20ths to the power of 0 if you want. And we would have that. Putting those numbers into your calculator, 0.00416 plus 0.00034 gives us 1 minus 0.00456, which is 0.995, then to 3 significant figures.